Hello friends, today's question. A simple harmonic motion is represented by the equation y, that is 5 times sine of 3 pi t plus square root of 3 cos 3 pi t centimeter. The amplitude and the time period of the motion are. So we have given a displacement equation for this SHM, and which consists of, you can say, two combination of two simple harmonic motion equations. So we can consider this sine as independent one, and we can also consider the cos as this independent one. So we can solve this question by using three methods, and let us try solving it one by one. So we can solve this by using three methods, and let us try solve it by using first method. So we given that phi of t is equal to 5 times sine of 3 pi t plus square root of 3 cos of 3 pi t. But the standard form for the equation for SHM is having only one trigonometric function. Okay. So we can say that standard form of SHM is y of t is equal to a sine of omega t plus phi, where a is the amplitude, omega is the angular frequency, and phi is the phase difference. So we have a as amplitude, omega is our angular frequency, and phi is the phase difference. So in order to, you can say, find out what will be the equation formation when the two trigonometric identities are combined together, so we can write this as y of t is equal to, this will be 5 sine of 3 pi t plus 5 times 3 square root of 3 rather cos of 3 pi t. And let us write it in the formation that y of t is equal to c1 sine of 3 pi t plus c2 cos of 3 pi t, where c1 is our 5 and c2 is our 5 square root of 3, and therefore we can represent this two function as a single function, and that can be written as single sine function and that function can be written as phi of t is equal to r sine of 3 pi t plus phi, where r is the resultant amplitude and will be equal to square root of c1 square plus c2 square. So this gives us 25 plus, and this will be giving us 75 square root. So this comes as 10. And from the equation itself, we can say that omega is equal to 3 pi. And from here we can say that time period is equal to 3 pi upon omega, and that will be equal to, this is 2 pi upon omega, and omega is 3 pi, so this is 2 pi upon 3 pi, giving us 2 by 3. So we get that the amplitude is equal to 10 centimeter, and time period is 2 by 3 seconds. So this is one method of solving it. Let us solve it by using second method. And in the second method, once again we are going to start with that y of t is equal to 5 sine of 3 pi t plus square root of 3, and we have cos of 3 pi t. So we can just open the bracket. This becomes y of t is equal to 5 sine of 3 pi t plus 5 square root of 3 cos of 3 pi t. So this is our first term, and this is our second term. So we can say that the first and second, these are the superposition of two SHM, and the phase difference between the two is pi by 2. Okay. So therefore from here we can say that y of t is superposition of two SHM with phase difference of pi by 2. So basically we can say phi is equal to pi by 2. Therefore we can once again write that the resultant R will be equal to a1 square a2 square plus a1 a2 cos of phi. Here a1 is our 5, a2 is our 5 square root of 3, and phi is our pi by 2. So here a1 is equal to 5, a2 is equal to 5 square root of 3, and we said that phi is equal to pi by 2. So once again we get R will be equal to 25 plus 75 plus 0, which is giving us square root of 100, that will go 10 centimeter. And once again omega is equal to over 3 pi, and time period is given as 2 pi upon omega, so this becomes 2 pi upon 3 pi. Pi and pi goes away, so we get this as 2.3 seconds. So once again the amplitude is equal to 10 centimeter, and time period is equal to 2 by 3 second. And let us try the third method, in which we are going to use make of trigonometric identities. So once again, y of t is equal to 5. We have here sine of 3 pi t plus square root of 3 cos of 3 pi t, and we divide and multiply by 2, so we get y of t is equal to 10 1 upon 2 sine of 3 pi t plus 1 upon square root of 3 upon 2 cos of 3 pi t. And we can convert 1 by 2 we know is cos of pi by 3, and square root of 3 pi by 2 is sine of pi by 3. So we can write y of t is equal to 10. This becomes cos of pi by 3 sine of 3 pi t plus sine of pi by 3 cos of 3 pi t. So this comes up cos A sine B plus sine B cos A. So we can write that y of t will equal 10 times sine of 3 pi t plus pi by 3. So we can make 1:1 comparison with the standard equation, which was our y of t is equal to a sine of 3 pi t plus 5. So from here you can say that our a is our 10 centimeter, which is our amplitude, and once again the time period will be equal to 2 pi upon omega. Omega is our 3 pi. We substitute here 2 pi upon 3 pi. Pi and pi cancels out, so we get this as 2 by 3 second. So amplitude is 10 centimeter and time period is 2 by 3 second. Okay, so the option is D is the correct one. So therefore we can write that option D is correct. So there were these 3 different methods to solve the same question. This completes the question. Thank you.